Hi there and welcome to the online course Easy Geosteering. Here we speak in simple words about main geosteering topics, making them easy to understand. We are currently in the first part of the course, Necessary Theory, and in the previous video we discussed the well trajectory and also defined measured and calculated values in the survey report. And today we're going to explore the next key definitions such as target layer and formation dip. Let's get started. The target layer is the productive part of the reservoir selected for drilling and development. You might hear different names like reservoir, productive formation, or zone of interest, but they all essentially mean the same. Here is an example, and we're looking at a heterogeneous formation, a mix of sandstone and shale. Make note that the type of formation doesn't really matter. If you learn how to use geosteering tools in one type of formation, you can easily apply those skills to any other. So, the choice of the specific target layer isn't a geosteering responsibility. That decision lies with the customer. But our responsibility is to drill inside the selected layer according to the drilling strategy, which implies the optimal trajectory for a specific well, considering all geological tasks and limitations while drilling. We will explore this topic in upcoming video number 6. So, to achieve an optimal trajectory, we need to define it with specific reference points. The most critical point, known as T1, is the intersection of the wellbore with the top of the target. The entire horizontal part depends on how we enter the target layer at this point. If the inclination is too high, we might land in a non-reservoir above the target. If the inclination is too low, we risk going straight to the bottom of the target, losing the productive length of the well. The next point is T2. This is where inclination first reaches 90 degrees. If your well has a downward profile and doesn't reach 90 degrees, T2 is the point where stabilization begins. And finally, we have T3 point, the end point of the well. Sometimes 3 points aren't enough to fully describe the trajectory. In such cases, we can define additional points labeled as M1, M2, and so on. In our example, we enter M1 at the beginning of the build-up interval, and M2 is where we stabilize again at 90 degrees. And one important note, the names of all these points can vary, because there is no universal standard and naming often depends on the company you are working with. However, the functions of these points remain the same. Okay, now let's have a look at the basic behavior of the target layer. The geosteering model consists of elementary blocks or segments, and for each segment there are just 3 options. It's either subhorizontal, dipping down, or dipping up. The dip angle is the angle between the layer and the horizontal level, and the main task for the geosteering engineer is to define this angle in each segment and keep the wellbore inside the target. How do we solve this task? With help of geosteering tools. Nowadays, the industry utilizes 7 key tools. In this course, we will discuss each one in details, exploring how they work, advantages and disadvantages, working environments and limitations. A few more words about layer behavior. Take a look at this cross-section. It is built in a west-east vertical plane. Here we can see the first well drilled with inclination of less than 90 degrees, and the second one with inclination greater than 90 degrees. What can we say about the layer? Is it dipping down or dipping up? What do you think? Well, since the concept of dip angle is relative, there are actually 2 correct answers. The layer is dipping down if we are looking along azimuth 90 degrees from west to east, and the layer is dipping up if we are looking along azimuth 270 degrees from east to west. That's why it's essential to assign the dip to a drilling azimuth or to use compass direction in order to avoid confusion. Okay, let's try some practice. Take a look at this horizontal well perfectly drilled inside the target. The cross-section is divided into 5 segments. Can you describe the layer behavior in each of these 5 segments? Take your time, you can pause the video, think it through, and then come back to check your answer. Okay, first we need to clarify the drilling direction. Based on the mutual positions of T1 and T3, the well here is drilled in the usual direction, left to right. In most cases you will see this standard orientation, but sometimes in geological projects or certain software you might see the inverse direction, right to left. So always pay attention to avoid confusion. Now let's look at the first segment. Here the layer is clearly dipping down. In the second segment, the layer appears to be subhorizontal. In the third segment, we cannot say just dipping up, because the layer is bending. It starts dipping up, but then transitions to become flat. In the geosteering model, we would split it into two separate segments with different dip angles. And finally, segments 4 and 5. These two show the same behavior. The bottom target remains subhorizontal while the top target is dipping down. We call this scenario thickness change, or we say the layer is pinching out. Alright, we have covered the target layer and its various behavior. Hope you like this video. Remember, you can enhance your practical geosteering skills with the private lessons. Together we will work in StarSteer to apply all geosteering tools and drilling simulators, so you can feel like a true geosteering engineer in real time. Stay tuned and give this video a thumbs up. In the next lesson we will explore the structure map and the offset well. See you then. Bye bye.